Ing. He's so good at teaching. I love math.
What?
Directions, it'll say use compositions to determine whether f of x and g of x are inverse functions. Well, compositions has a notation that looks like function notation, okay? And how do you do this? Well, the two functions f and g are inverse functions if and only if f of g of x equals x and g of f of x equals x. What does that mean? If you can put g into the function f and your result is x, and you do that over here as well, you take the f of x function and you put it into g and your outcome is x. If both of those happen, then they are inverses. So let's write that summary. Both equal to x, then yes, they are inverses. But that means the opposite is true. If both not equal to x, no, they are not inverses. Okay? Alright, B1, let's see if these are inverses. The f of x function, we're going to put in g of x. So if it looks like this, that means every time we see x now, we're going to write, let's just color code this, every time I see an x now, I'm going to write g of x. So let's do that with my, so f, now we're going to put in g of x. Well, that would be kind of silly if we just left a g there, so we're just going to go ahead and simplify that. So negative 8 plus that goes here. So now I can write 2x plus 8. Whoops. Put in parentheses. And then we just simplify. I don't need the parentheses, so negative 8 and a positive 8 equals 0. So I have 2x over 2. And then you can just cancel your 2's, so that is equal to x. So f of g of x equals to x. This is a good thing. Okay, let's go ahead and do the same thing now over for g. G of x equals 2x plus 8. And now, every time we see x, we're going to put in a f of x. Let's do that. So I have a g. We're going to put now in f of x. 2 times that plus 8. Well, instead of writing f of x, you go back over here, you're going to be writing negative 8 plus x plus 2. Let's write that. Oops. Equals 2 times negative x plus 8 plus x over 2 plus 8. Alright, let's go ahead and simplify this. To make 2 a fraction, you can put over 1. 2 divided by 2 is 1, so you're just left with the original now. Negative 8 plus x plus 8, and negative 8 and a positive 8 equal x. So g of f of x equals x, and that is a good thing because now they're both equal to x, and if they're both equal to x, then we can say yes, they are inverses. B2, use compositions to determine whether f and g of x are inverse functions. To do that, we're going to find our first problem we need to do is write our f of x and let's use purple. We're going to be writing a g of x for every x value. Let's go ahead and do that. So I have f negative 4 plus 9. Then using my purple, we can write g of x. But instead of writing g of x, in purple there, we're going to have to write x minus 4 over 9. Now, the left side looks kind of weird, so you don't have to do anything over there. All right, let's go ahead and simplify over here. Negative 4 is a fraction by bringing it over 1. Excuse me, wrote the problem wrong. That would have been bad. Negative 9. So negative 9. Okay. So if I wanted to simplify this one, if I do negative 4 divided by negative 9, I just get positive 4 ninths. Okay, this is not looking good. I mean, you could do something like this. You can distribute, so you would get uh, 4 ninths x, and then 4 ninths times negative 4, and then you would have plus 9. Clear this out of the way. So that would give me 4 ninths x. This would be over 1. Then you have multiply there, so you have negative 16 over 9. If you wanted to change this one, you can do 9 over 9. That would give me 81 over 9. And then you can do 4 ninths x, negative 16 plus 81. I'm going to put that in my calculator. Positive 65 over 9. Okay, question. Does that equal to x? The answer would be no. Let's double check by doing the other one. So you have g is my pen not writing? Let's see. Oh, it's on eraser. G of x minus 4 over negative 9. And what we're doing here now is we're putting this g of x into here. I'm going to do it twice. Okay, so we're going to put in an f of x here. Instead of writing f of x now, we're going to write negative 4x plus 9. So this is what we have so far. Okay, so I don't need the parentheses, so you can just add those. So you would have negative 4x plus 5 over negative 9. And if you wanted to, you can just clean that up. This is negative 4 ninths x divided by negative 9 and positive 5 over negative 9, which would give you 4 ninths x minus 5 ninths. But again, here's the question. Does this equal to x? And the answer is no. So no, not inverses. B3, let's see if these are inverses. I'm basically just going to take the g of x and put it for every x value. So you're going to put a g of x here, g of x here. These are called compositions. And instead of writing g of x, we are going to write square root of x minus 2. And everything in blue is the same. Don't worry about the left side. So let's work on the right side over here. I'm going to work inside these blue parentheses, and I don't need that one, so I can just combine like terms. Negative 2 minus 2 is minus 4. Remember, when you have two of these, you have this. Okay, be careful now. You have to use FOIL, or you can use the box method, which I've taught you guys earlier this year, so I'm going to use the box. Keeps me organized. I like it. Whoops. We're going to multiply, then we'll add. Square root of x times the square root of x is going to be x. This is like this. So what is the square root of x squared? These are opposites, and the only thing that will be left is just the red there, the radicand, x. Negative 4 times square root of x is negative 4 square root of x. Negative 4 times square root of x is negative 4. It's multiplication, but they put the number in front. And negative 4 times negative 4 is 16. So here, we would get x, negative 4 and negative 4 is negative 8, square root of x plus 16. Okay, question. Is this equal to x? The answer is no. So you can just stop there. You can do the other side too. We'll do that really quickly. So all of this would go here. Be kind of complicated on this one. But it doesn't matter which side you start with. Does that make sense? So f of x in blue there is x minus 2 squared, and all that is squared root minus 2, and so these are opposites. These will cancel. So you're just left with x minus 2, and you'll get x minus 4. The question is this equal to x? And the answer is no, it's not. So no, not inverses. Or use compositions to determine whether f of x and g of x are inverse functions. Okay, this problem's a little bit different because it has this part here, and this is just called a restriction. Basically, if you think about it on the graph, this is 5x squared power function, and then they're telling you based off this restriction the graph is only in this direction right there. That's what it means. So when you use the compositions, you kind of need that restriction, but for our purposes we can just do the problem. Alright, so I'm going to take all of this and put it for every x value. So I have f of x 5 times this. You don't need to write the restriction anymore. Okay, we're putting in g of x, and g of x is the square root of x over 5. Don't worry about the left side. Okay, so I'm going to write out, we have to use PEMDAS, and what we're doing here is we're not solving, we're simplifying. Which means we're going to do parentheses and exponents first. So the power of 2 just means that there are 2 of these. Okay. The square root of x times the square root of x is really x times x, which is x squared, and those are opposites. So all of that gets canceled and you're just left with x right there. You still have that 5 in the numerator, and 5 times 5 is 25. Now that I realize I should have just kept it 5 times 5. Why? Why do you think? Why do you think? Well, my 5's cancel and you're left with I think we messed up somewhere. I messed up somewhere. Let's take a look. Square root of x over 5. It's not my fault. It's the textbook's fault. This was actually supposed to be all of it in the square root. Okay, what does that change? That just basically means both the x and the denominator has a square root of 5. That is a big idea, because then here this would be square root of 5 times square root of 5 is the square root of which is just 5. That's the big idea. Okay, what does that mean for us? Then I can just cancel these 5's and it is equal to x. Okay. That is good. Okay, now we gotta check the other side. Let's do it. Okay, now we're gonna draw a every time I see x, I'm now gonna write g of x. So I have a g, but now instead of writing x, we're going to put in an f of x. And instead of putting f of x, we're going to be putting in 5x squared. and all the green. Okay, over here, they're both inside the square root, so you can do something like this. And you could do a couple of things here. You can break them up. And there you would see radical 5 divided by radical 5 is 1. Another way you can see that is up here, you can cancel out those 5s if you wanted to as well. And this one we did over here, which is just x. So right here, this one is just x. So if they're both equal to x, then they are what? Inverses. These compositions determine whether f of x and g of x are inverses of the functions. Let's take this one, g of x, and we're going to write that for every x value. And you're kind of doing that twice, so I'm going to give more space. So f 2 times the cube root of g of x plus 3. Whoops, we weren't supposed to write that part. And now I am writing this here, g of x. And g of x is x cubed over 8 minus 3. X cubed over 8 minus 3. Don't worry about the left side, it looks weird. Don't forget the plus 3. Okay, let's simplify this. Well, inside the cube root, because it's power 3, the negative 8 and the positive 3 are 0. So this is good. Okay, so with that fraction now, we can actually just separate them. What I mean by that is you have the cube root of x to the third all over the cube root of 8. Well, again, this means, do you have 3 of these to come out? Yeah, 1, 2, 3. They hold hands, they come outside, no more radical. They're not inside the house anymore, okay? If you look at this one, same thing, but it's in the denominator, so they can hold hands and come outside, okay? So you have 2 times x over 2. Make this a 1, and then your 2's will cancel, and it's equal to x. Very good, right? All right, let's try it the other way now. I need a blue highlight. That's what we're going to put in for every x value. I'm going to do it twice. Okay, let's write it. So I have g of x equals x cubed over 8 minus 3. And now we are inputting f of x in here. But instead of putting f of x, we are putting in now 2 times the cube root of x plus 3. 2 times the cube root of x plus 3. What we highlighted in the left blue box on the top left there. And in green, they are the same. Don't be intimidated. Okay. Let's simplify this. So number 1, this power 3 and the radical sign with the power 3 are now gone. Okay. This will leave us with 2 times x plus 3 over, let me think about this really quickly. I'm only saying that because they've messed up a couple of times on okay, we did it that way. Yeah. Gotta make sure this is right. X cubed. F goes into G. We did that. Correct. All of that over 8 minus 3. Okay, good. Okay, so we're just left with the x plus 3. I see my mistake. Okay, my mistake was this power of 3 goes both to the 2, like right here in blue, and so let me put that in a different color. How about black? This power of 3, it's not black, black, goes here and here. That was my mistake. Alright, let's keep simplifying this. So 2 to the 3rd power here is 8 over 8. The 3 and the cube root is gone, so you're only left with just x plus 3. And to be careful, you have to put that in parentheses. Minus 3. Almost done. So then you have 8 divided by 8, so you have x plus 3 minus 3. And then these negative 3's will cancel, and then you're just left with x, which means they are inverses. Awesome. See you guys. Use compositions to determine whether f of x and g of x are inverse functions. Let's go ahead and put the g of x in for every x. Let's go ahead and write out the original problem in blue. And you'll notice I left a gap for the substitutions there. And what are we going to put in there? G of x. And g of x now we're going to write as x over 3 to cube root. And same thing, oops, forgot the minus 1, very important. X over 3 minus 1. And the blue will stay the same. Don't worry about the left side. Okay, and you can always double check that because it's confusing. You have the 3 there. There in green you have the g of x plus 1 and the power of 3. Okay? Alright, let's see. So, inside, let's use the parentheses here in red. In the parentheses here, you have this minus 1 and the plus 1. And those will just cancel. So then you're left with 3 times x cubed and 3 cubed, all to the power of 3. Okay, so this power of 3 now goes here and here. Let me write it a second time so you can kind of see that. So we have 3 in the numerator cube root of x, cube root of 3, and remember those are all opposites. So the only thing you're left with is just, let's do that in blue, different color, 3x all over 3. And that is equal to x. So that is a good thing. Okay? Let's try it the other way around. Let's put in f of x now for every x value that we see. Okay? Alright, let's write out our green for g of x. And we're putting in f of x. But now the f of x is 3 times x plus 1 to the third power. So I have this g function, cube root of all this, and that minus 1 is on the outside. Okay? Okay, so what can we do here? Well, these 3's, 3 divided by 3 is 1, so now you have the cube root of x plus 1 to the third power minus 1. And then again, same thing, this 3 and the cube root out here are opposites, so you're just left what's inside. So now we have x plus 1 and that minus 1. Negative 1 plus 1, that will equal x. So that is good. They're both equal to x, therefore they are inverses. Woo-woo. See you guys.
It's lonely at the top. All of my enemies have been defeated. This math has been sitting in my head for too long. It's starting to give me these lesions. Follow the formula gives reasons. Stay solving and uncovering all of the reasons. Multiplication, division, subtraction, and then we got fractions and algebra. Just seven, I got the angles, I'm busting, finding the key. I'm almost breaking and finding the answer solutions. I'm ready to uncover the problem. Open up, knock, knock here, cause I'm number 9,124. Oh no, making a mess, my counting the best. I guess I should clean this all up and go home.